I am Manvit and this is my project Atomic Editor. This is a theoretical chemistry based website made in HTML, CSS and JavaScript. As we can see, this website consists of three web pages. The file names are index.html, rules.html and atomiceditor.html. In this project, we are going to explore basic fundamentals of atomic chemistry and how the renowned chemist and scientist Niels Bohr chose to implement it. In index.html, I've given a brief introduction to this project. In rules.html, I've listed a few rules that you need to know and are important for you to solve and use this project's editor page. In atomiceditor.html, it has the skeleton of the sole purpose of this project, atomic editing. As we can expect, style.css file has been used to stylize this project so that it can get a good look and a premium look. Script.javascript is a really huge file. I know it's somewhat 1,000 lines, but it contains the brains of this project. It defines the logic of how atomic editing works. Let's see it live. As you can see, this is the home page. This is the rules page with a few rules that it's better if you read them. And this is where fun begins. This is the editor page. As we can see, we are given hydrogen as the base to start editing because hydrogen has the least number of shells, electrons, neutrons, and protons. This side panel, which we can guess it at atom information, has the information about the atom that is currently being edited here. Currently we are doing nothing, so it's just hydrogen, a stable non-ionic hydrogen. We can see atomic number, mass number, protons, neutrons, electrons, charge, valency. Valency will only appear when these stability rules are satisfied. When it's nuclearly stable and ionically stable, then we can see valency. These buttons, if we press them, the fun now actually begins. If I add an electron, we can see the net charge is -1. Why? See, net charge is number of protons minus number of electrons. We can see there's only one proton and two electrons. It means it has a minus charge, a negative charge. To balance it out, as you guess, we have to add another proton. But the fundamental rule in chemistry is that if you add a proton, it changes the element and its chemical properties. So as we can see, the element's name is helium because it has an atomic number of 2, that is 2 protons. But this is kind of concerning, unstable, because the atomic mass of helium is 4. What else constitutes to mass in a nucleus? As you guessed it, it's neutrons. So we do the obvious, add neutrons. Now we can see valency is again appearing here because it's nuclearly stable and ionically stable. Valency is 0 because helium is a noble gas. Its duplet configuration is complete. Now let's change it. Why not? I've added another electron. As you can see, the next shell and electron has been default added. It's handled in the code in script.javascript. I can add another electron. I can add as much as I want. But the thing is, I can add infinitely many electrons, but in a shell, only 8 electrons can be allowed. This is up to 20 elements, so that's why I've limited the number of protons to be added to 20. Because after that, the Bohr-Berry principle just starts to break. Now this is, oh my god, it's critical. So let's add a few protons. Boron. We get the element boron. It's still unstable because we haven't added neutrons yet. Let's add it. We can add it like this. We can add a few more protons. As you can see, the element names keeps changing. Sodium, magnesium, aluminium. It can go up till calcium. Now let's balance this out. Let's add more neutrons to make its nucleus stable. Now let's add electrons. And there we see valency comes back, net charge is 0. And if you scroll down a little bit, we see this category called electron shells. Shell 1, shell 2, shell 3. The main idea of Bohr's model is that the energy level of a shell and the velocity of an electron or electrons in that shell is quantized. That means it's fixed. It can't be changed. It can't be more than what we've calculated. It can't be less than what we've calculated. So there is a formula to calculate energy level of a shell. There's a formula to calculate velocity of a shell, velocity of the electrons in that shell. And we can just keep on adding shells. We can keep on adding electrons, but not protons because it's limited. Let's add neutrons because why not? Let's add a few more electrons. Let's fill everything. Yeah, so we filled everything. Well, I would like to show you guys another feature or another revolutionary concept that I've implemented as a feature. Let's reload it so we get back hydrogen. The purpose that Bohr invented his model and his approach was because during that time, when he was still interested in the atomic structure, there was a problem. We know that light disperses itself when it's passed through a prism into 7 different colors. But the interesting thing is, if you pass that same light through a hydrogen gas and then let it be dispersed when put it into a prism, we get only a specific colors. This troubled a lot of scientists back then. Well, Bohr was too smart. So he did what no one expected. He quantized energy, he quantized velocity. That's the reason we have minus 13.6 here and specifically 2.18. Because that's how his model works. Everything is quantized. Well, according to him, you can add how many shells as you want. It can be infinite. An atom can have infinite number of shells. At the number equals to infinity, the energy level is 0. That means if we add infinite number of shells, we won't be seeing any minus 13.6, 12.6, nothing. We would just see 0 electron volts. So yeah, let's use that advantage and let's add a few shells. So, well, there's a principle in Bohr's model that electrons can jump from shells to shells depending on how much energy they've absorbed and how much energy they'll radiate. To jump from a lower shell to a higher shell, they need to absorb certain energy, and to come back, it will radiate that energy it has absorbed. So let's do this. If we can drag this electron and we can put it somewhere. If we use Alt and put it on a shell, it will roam permanently there. It's important, I'll tell you. Wait a minute. As we can see, it's being highlighted. Well, to solve this hydrogen spectrum problem, Bohr decided to put this electron permanently in the second shell. So we can hold Alt and drag it here. So we can see that pop-up, it says 10.2 electron volts has been absorbed because it's minus 13.6 electron volts in the first shell and minus 3.4. If you do the math, you get 10.2 electron volts absorbed. Now, let's actually see the fun of Bohr's model. So as we know, he said that when electrons jump from a higher orbit to a lower orbit or a higher shell to a lower shell, they have to radiate that energy. So let's see that. Alright, we can see it's being highlighted again. Let's put it in the third shell and let's see what happens. There, did you see that light? 656 nanometers. It's the color of red. It is also the first color that comes out of the prism when put through hydrogen gas, when the light is put through hydrogen gas. Now we are seeing it's highlighted again. Let's put it in the fourth shell and see what happens. There you see it's kind of a blue. It's kind of blue. It's the same as the color of electron I'm using here. It is the second color that comes out of the prism when the light is put through hydrogen gas. Let's see it again. Let's put it in the fifth shell. As we can see, it's highlighting again, so that means it's ready. Let's put it in the fifth shell. And there we go. We get a dark blue, which is the third color that comes out of the prism when the light is passed through hydrogen gas. And when these calculations were seen as correct, they accepted the Bohr's calculation and his model as a valid proof, a valid mathematical proof for how hydrogen behaves. As we can see, these are the features of this project. That's it. This was CS50.